Welcome back to Summarize Science. Today, we're diving into a paper that could fundamentally change how we build intelligent robots. One of the biggest hurdles in robotics is data. Getting enough real-world examples for an AI to learn from is incredibly expensive and time-consuming. Current methods often just throw massive amounts of data at a model, which is inefficient and doesn't guarantee it will learn what it needs to. This is where the new research comes in, proposing a system inspired by how humans learn. Think about it. When you learn a new skill, you don't just randomly repeat things. You focus on what you're bad at, practicing deliberately to fix your weaknesses. The researchers call this computational metacognition, essentially, teaching an AI to think about its own learning process. They developed a framework called Deliberate Practice Policy Optimization, or DPPO. The process works in a two-stage loop. First, in the reinforcement learning phase, the AI tries to complete tasks on its own. This is an exploration stage where the system identifies all the hard cases and failures. It's like a self-diagnosis, figuring out exactly where its knowledge gaps are. Then comes the second phase, supervised fine-tuning. These identified weaknesses are sent to a more powerful teacher AI, which generates high-quality, correct solutions. The student AI then studies these targeted examples to refine its skills and patch its weaknesses. This cycle of reveal weakness, then refine weakness repeats, allowing the AI to continuously improve in a highly efficient way. Using this powerful training method, the team created a new vision language model called pelican-vl. And the results are pretty stunning. Pelican-vl achieved a massive 20.3% performance boost compared to the base model it started with. Even more impressively, it managed to outperform other open-source models that are significantly larger and more computationally expensive. As you can see in these tables, it's competing with and even beating models in the 100 billion parameter class. So, let's recap why this is such a big deal. First, this DPPO framework is a smarter way to learn, making much more efficient use of limited and expensive data. Second, it shifts AI training from a passive process of data consumption to an active process of self-improvement. The AI isn't just learning a task, it's learning how to learn more effectively. This breakthrough represents a major step towards creating autonomous, self-evolving intelligence. Imagine robots in the real world that can identify their own shortcomings and actively seek out the knowledge to improve without constant human supervision. The researchers believe this could be the foundation for a ChatGPT moment for robotics. Thanks for joining us on Summarize Science.